Let's get started on this review. The three primary equations we're going to use to write out our linear equations, you're going to have your point slope. And when you write this equation, you'll notice that I have a point, that y1, x1, and I've got a slope, which is the m that I have right here. So I've got a point, I've got a slope, point slope. I've also got a slope intercept. It's the one we use the most. When we solve down, this is the y equals mx plus b. And it's called sloped intercept because I've got a slope and I've got an intercept in my equation. The final one is just the slope equation. I've got y2 minus y1 on top, so the difference in my y's as it's related to the difference in my x's. That is my slope equation. Those are the three equations we use most often. Now, they want it in slope-intercept form, which means we need y solved for. We've got a slope of 3/5 and an intercept of -1. I can go straight to my y equals mx plus b form with this. Y is equal to 3/5x, which is my slope, minus 1, because it tells me my intercept. My second one, I've got 2 points. I need to calculate my slope, so I'm going to take 3 minus -1 over 2 minus 0. You're going to get 4/2, or a slope value of just 2. They give me the y-intercept, so I'm going to use that. Y equal 2x for my slope, and then my intercept is -1. On number 4, they don't give us the intercept, so we're going to solve for slope just like we did in the previous one. 6 minus -2 over -3 minus 1. That gives me 8 over -4, or just -2. And since I don't have my y-intercept, I'm going to pick one of these 2 points. I'll use this one. Pick one of these 2 points and solve for it using point slope. So I have y minus -2 is equal to -2x minus 1. And I'm going to take this equation, muscle it down, and get y isolated. Pull that 2 from both sides, and I'll get y equal -2x. On number 5, I want to be parallel to this line. I want to go through this point. If I'm parallel to this line, I'm going to have the same slope. So my new slope is going to be 3. Just like my old slope was. And I'm going to use point slope. So y is equal, or y minus rather, 3 is equal to 3, x minus -2. And then I need to solve this for y, so I can get it into point slope form. Add the 3, and I'll get y is equal to 3x plus 9. Number 6, want to be perpendicular to this line, and I want to go through the point 1, -4. So perpendicular is going to have an opposite reciprocal slope. So instead of -1/2, I'm going to have positive 2/1. I've got my slope, I've got the point that I want. Y minus -4 is equal to m x minus x1. Again, solving down for y. Always got to solve for y on these bad boys in case you may want to graph it. And we're ready. 7. We want to be parallel to y equals 6. Now there are 2 ways you can do this. The first you can say is that the m is equal to 0. Once the m is equal to 0, you've got y minus -3 is equal to 0. X minus 5, since the horizontal line, no slope. And you'll get y plus 3 is equal to 0, y equal -3. The other way you can do this, and you'll get the same answer, is if I have a grid, and I get my line y equals 6. We'll put it right up here. It's actually solid, but just so you can see the difference. We've got y equals 6 right here. And then 5, -3, let's call that point right there. If I want to be parallel, I'm going to have another flat line. Going to have another flat line. What kind of an equation gives us a flat line like that? We got to have a y equals equation. Well, what is y going to be equal to? It's equal to -3 at this point. So it's going to have to be equal to -3 at all those other points as well. And that's how you can set that up without muscling through any equations. Number 8, graphing each system. These are nice and set up for us. I've got +1 for my intercept. I've got -2/3 for my slope, so down 2/3. When we're graphing for intersection, it's a good idea to get just a whole bunch of points. As many points as you can fit on that grid. We try to do a good job of giving you numbers that cross real nicely. They may cross in a quadrant you don't expect, but they will cross somewhere real nice for this particular test. And you just want to make sure you graph them correctly. So I've got my first one, y equal negative 2 over 3x plus 1. I got my second one, y equal x plus 1. Got those in. They cross right here at 0, 1. And we move on. On this one, don't be fooled. Y is on the other side. We still have a slope of 1. We still have an intercept of 4. Just like the previous time, make sure you get just a whole bunch of points. And then on this one, got to solve for y. If we don't solve for y, there's a problem. All right? Because you cannot identify that slope and that intercept correctly. So I've got y solved for. I've got a slope of negative 2. Notice it's going to cross back behind the lines. So you're going to want to get all those points. Get some nice points in there. Get your solution looking real good. Again, negative 1, positive 3 is that point of intersection. Moving onward to number 10, I've got y equal 2x minus 4. Negative 4 is my starting point. 2 is my slope. Get some of these points. I'm going to go down one touch. That's my first line, y equals 2x minus 4. Y equal positive 4. It's going to be my other line. I've got that dot at 4. Be a horizontal line. Terrible line. Gracious. 4, 4. Going to be my intersection. Last one on this page. Again, going to want to solve for y before we get started, so I'm going to pull that 8 from both sides. 2y equal 4x minus 8. Divide everything by 2. I'll get y equal 2x minus 4. Now some of you already can tell that these two lines are going to be parallel. The slopes match up. So I know that they're going to be no solution. But on the test and for me, you're going to take and visually demonstrate that they're not going to cross. So I've got my first line right here. My second line starts at negative 4. Still got that slope of positive 2. And you will notice they will not cross. Looking real nice. Here we go. We're going to check out. Now, the difference between these and your other graphs is that these you're going to have to shade. So you're not only going to take and draw the line, but you're also going to shade where those answers could be as well. When we look at this first one, y is already solved for. So I've got a minus 1 on my intercept. I've got a 1 over 3 for my slope. Nice looking line, going to be right here. It's going to be dotted because I don't have the equivalency bar, so we must be greater than the line. We cannot be equal to it. And it'll be shaded up here. My second line, I'm going to use this fancy green color. It's not solved for y, so I'm going to have to get that 1 to the other side, and now I'm ready to go. So I got a plus 1 for my intercept. I've got a positive 1 also for my slope, so I'm going to get some points. This line is also going to be dotted. There's no equivalency bar, so we can be less than this line, but we cannot be on it. And it would be shaded down here. Where those two shaded regions cross is your solution. This area of the graph is both greater than the first line and less than the second line. Therefore, solution. This one, intercept of 3, slope of 2. Get ourselves some nice points here. Get a dotted line. I want to be less than this line. And then on this one, got to pull that 3x from both sides. 2y is equal to negative 3x. 2y really is less than or equal to negative 3x plus 4. Pull that 2 off of both sides. Y is less than or equal to negative 3 over 2x plus 2. And then down 3 over 2, down 3 over 2. Going to get some of those reverse points as well. And this time solid line, because y can be equal to this line. We want to be less than as well. So I'd take it, shade down. Right in there. It's where those two regions cross, so it's where both lines are true.